Unit 8 Fractions Booklet 3 Characteristics. F of x equals 6 times x plus 2 times x minus 2 all over 2 times x plus 2 x plus 1. We want to find these characteristics using this given function. To find a whole, that is when part of the graph is not continuous at that point, otherwise known as a removable discontinuity. It's when the factors cancel out in the fraction. These are both x plus 2 in the numerator and the denominator, so those cancel out. 6 over 2 also reduces to 3 over 1. So then we have 3x minus 2 over x plus 1. To find the whole, we're going to set the thing that we canceled out equal to 0. So negative 2 would be the x part of the whole. And then to get the y value, you just plug in that x value, negative 2, into this expression. That's going to give you 3 times negative 4 over negative 1 is 12. Okay, now for the vertical asymptote. After we've simplified our expression, we're ready to find the vertical asymptotes, if there are any. We'll go ahead and rewrite it. So the vertical asymptote, we set the denominator equal to 0. X equals negative 1. So for this one, you set the denominator equal to 0. And you need to do that after you cancel out the wholes. And we'll use the vertical asymptote to find the domain. The domain would be all real numbers except those two undefined numbers, negative 2 and negative 1. So we have negative infinity to negative 2, union negative 2 to negative 1, union negative 1 to infinity. So for the domain, it's all real numbers except for the wholes and vertical asymptotes. For the horizontal asymptote, we want to take the leading term of each numerator and denominator expressions. We have 3x minus 6 over 1x plus 1. We have 3 over 1. And also the leading coefficients must have the same degree. If they don't, you'll put a 0x to some power to make that so. Alright, for the x-intercept, you want to set the numerator equal to 0. And then for the y-intercept, you plug in x is equal to 0. So then we get 3 times negative 2 over 1. It's negative 6. Again, you need to find all of these after the wholes. Alright, let's go to the next one. F of x equals 8 parentheses x minus 2 times x plus 2 all over 2 times x minus 2 times x minus 1 times x plus 1. Okay, let's simplify. 8 over 2 reduces to 4 over 1. The x minus 2's cancel out. So now we can find our whole. Set x minus 2 equal to 0. X equals 2. To find the y value, you plug in 2 into the reduced fraction. (16 over 3 would be your y value. Next we'll find the vertical asymptote, also known as VA. So rewrite our simplified function. 4x plus 2 all over x minus 1, x plus 1. Alright, set the denominators equal to 0. In this case, there's 2 of them. So your domain is going to be all real numbers except xk equal 2, negative 1, or positive 1. For horizontal asymptotes, we find the leading term of the numerator and the denominator. Now notice they're not the same degree. You have to make them have the same degree first. So I have 0x squared plus 4x plus 8 all over 1x squared minus 1. Now they have the same degree. You divide the coefficients. Y equals 0. Okay, for x-intercepts, plug in, set the numerator equal to 0. Of negative 2, 0. And then for the y-intercept, evaluate when x is 0. Before moving on to the next page, answer this question. What are the differences between vertical and horizontal asymptotes? Answer the question in the box provided. Pause the video and then move on once you've answered the question. Find the oblique asymptote. Use synthetic division. X squared minus 13x plus 31 all over x minus 6. To use synthetic division, we set up our box and we put a 6 inside of it. We set the denominator equal to 0. And then we'll have the coefficients of the numerator, 1, negative 13, and 31. Break down the first coefficient. From here, to get this number, we do 1 times 6. And then we combine those. Six times negative 7, and minus 42. And then the remainder is negative 11. Since the remainder is not 0, you have an oblique asymptote. Your oblique asymptote would be at y equals x minus 7. So this is the x, this is the constant. Simplify completely, then identify the characteristics. You'll use synthetic division on this one. So in the box, we'll put 2. The coefficients in the numerator is 7, negative 18, and 8. Break down the 7. 2 times 7 is 14. Negative 4 times 2 is negative 8. You have a remainder of 0. So that means our quotient is going to be 7x minus 4. To get the x-intercept, we set that equal to 0. Divide by 7. So x is going to be 4/7. And then the whole, since the remainder is 0, there was a factor that canceled out. So we know that 2 is the x value. To get the y value, plug that into the quotient. Ten is the y value. And for the horizontal asymptote, well, there's nothing in the denominator left. There's just a whole that we took away. So there's none. Also, if you look at the original, we would have the leading terms (7x squared) and 0x squared. 7 over 0 is undefined. So I'll take a moment and answer this right here. Describe the process for using synthetic division here. So in your own words, describe this process that we used to get the quotient. Pause the video, and once you've answered the question in the box, move on. Which transformations occurred from f of x equals 1 over x to g of x equals negative 9.2 over x plus 3 minus 4? There was a reflection because of this negative sign right here. For the dilation, there was a vertical stretch because 9.2 is larger than 1. Horizontal translation, it goes to the left 3. For vertical translation, it goes down 4. Remember, for up, it will be a plus number. Down will be a minus number on the outside. None will not have a number. For horizontal translations, for left, it will be plus number on the inside of the parentheses. For right, it will be a minus number on the inside of the parentheses. And then for none, there would not be a number in the parentheses. And for dilation, stretches, the number not counting the sign would be bigger than 1. Vertical compression, the number would be smaller than 1. And none, it would either be 1 or negative 1. And then for reflections, they would have a minus on the outside. If it was a no, it would just be a plus. Or nothing at all. Alright, let's analyze these graphs on the last page. This type of rational graph is an odd rational graph. It has a hole right here at -3, -2. Frequently, when you graph these using technology, it will not show the hole itself. For the vertical asymptote, it's going to be this line right here. So x equals -2. And then so the domain is all real numbers except -3 and -2. So an interval notation, that would look like this. Negative infinity to -3, union -3 to -2, union -2 to infinity. For the horizontal asymptote, it's right here. Y equals -1. And then for the range on this one, it would be all real numbers except this -2 and this -1. So interval notation, it would look like this. Negative infinity to -2, union -2 to -1, union -1 to infinity. The x-intercept is right here at -1, 0. And then the y-intercept is right here. Looks like it's about 0, -1/2. Let's look at this rational graph. This one is an even rational function. The whole is right here at -2, 3. The vertical asymptote is going to be at x equals -1. And the domain's going to be all real numbers except for -2 and -1. So -infinity, -2, union, -2 to -1, union, -1 to infinity. For a horizontal asymptote, it would be right here at y equals 4. And then the range would be anything below 4 except for this whole, but if you look at it, it actually is in the range right there, so it's just all real numbers less than 4. -infinity to 4. You also put y is less than 4. For the x-intercepts, there's 2 here. -1/2, 0, and like -2.50. And then for the y-intercept, that'd be this point right here, 0, 3. Before moving on to the next section, answer this question in the box. What are the differences between even and odd rational functions? Compare and contrast the graphs from the examples right here in this box.